Hey guys, welcome back to the channel. Today on the channel, we're going to be looking at the power supply board on this realistic STA-2100. So in the previous video, we swapped out the power switch, and guess what? We got everything working, it's making music, and it sounds good. So we're going to continue on with our restoration process, and that begins with our power supply. So what we're going to do with the power supply is we're going to change out the transistors and all the electrolytic capacitors on that board. So without further ado, let's come on in closer and let's get started. All right, guys, so this is the top of the unit. And as I previously stated, this thing looks really good inside. So we got that famous toroidal transformer that Pioneer sued over. We've got our amp boards, our tuner board, and then this is our power supply board. So I just wanted to show you guys the top part of it, but in order to access this power supply board, we're actually going to have to come from the bottom, and there's a few screws we're going to have to take loose. So let's go ahead and flip this over. All right, guys, now we have the receiver flipped over and looking at the bottom of the receiver. And so this is our power supply board, and so there's a few screws we're going to have to take out to get access to this board. And so we have a screw here and here, and I'll take a picture of this just to kind of give a better illustration. And then on either side, you guys will see this metal brackets. And then each one of those is attached by a single screw down, straight down at the bottom on either one. And so I'll throw a picture of that up on the screen, and so we'll have to take those out. And that just gives us a little more play and makes it a little bit easier, I think, to get to this. I may try to just take out these first two screws and see if we can get it out, but I think I'm going to have to take those screw brackets out as well. From there, I'm probably going to have to cut a couple of these ties and then loosen up this, or take out this screw here, which is basically holding our ground wires. And from there, I believe I'll be able to get access to this board and just pull it out, and we can start working on it. So I'm going to go ahead and do that. You guys just hang out for the ride. A little patience and going back and forth, we were able to get this board out. So now we'll have access to this back side, and we can start soldering and taking out some of these components. And so let's do a count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 electrolytic capacitors. And it looks like we have 1, 2, 3, 4, 5 transistors. And so we're going to swap all of those out. This is that fuse, guys, that I was telling you came loose. And so if you notice, the actual holder broke. So what I did is I just soldered it in there. I think I have new clips for this, and if I do, I'm going to go ahead and replace those while I'm at it as well. So I'm going to go ahead and gather my parts, guys, and then we'll get ready to go ahead and start swapping out some of these components. So here we are back at the unit, guys. As you can see, I've got this access to this power supply board pretty well. And so I've gone ahead and sourced my parts. And so the way I do that is I go and I find the service manual and I compare the transistors, and then I kind of look at the board as well. And so for the capacitors, sometimes there could be some changes. So I kind of want to talk briefly over how I do that process, because I know we have new people always tuning in. And so if you want to skip ahead, if you've heard this speech before, you guys can skip ahead. But anytime I do transistor swapping, guys, I have basically put together a spreadsheet that I keep a lot of these transistor swaps in. And so then if I don't remember, I'll go back. But another thing I do is I'll go and look at the service manual. And then, as you can see on here, I'll go ahead and trace out lines and basically write on there what transistor goes to it and, you know, make it colorful so it's easy to pinpoint. There's a couple transistors that I want to point out on this board that are, one particular is a KSA 708. And so that pinout is different than a lot of the transistors I deal with. And so most of the transistors that I'm dealing with is going to be a ECB. But however, this pinout for that 708 is actually a EBC, which is different than a lot of them. So those are things you want to make sure you pay attention to. And then when we talk about transistor swapping, if you don't know what you're doing, guys, make sure that you do your research and that you're very, very familiar, because it could damage your equipment or it could just not work when you do swap out these transistors. And so each transistor will have 3 legs. And so this is a KSC 2073 that I'm holding in my hand. And so this resistor has a pinout of BCE, but each one can be different. And so you want to make sure that you're familiar with the characteristics of your transistor. If you go to Mauser or DigiKey, you can always look up the data sheets and then see what the pinout is. And you want to make sure that you have that pinout correctly before you go ahead and put it into the board. I'll go ahead and throw up the symbol for a transistor up here on the screen. That way you guys can take a look at that, because you're going to use that information, basically knowing what the emitter, the base, and the collector is when you're putting them into the board itself, because it'll have that pattern on the board and you want to make sure you do it correctly. So moving on to capacitors. And so capacitors, I've got a lot of questions previously in emails about capacitor swapping. And so anytime that I do this, I always check the service manual to see what capacitors. But a lot of times, sometimes as they're making the boards or as they're installing components, they may make changes that are not documented in the service manual. And in that case, you want to make sure that you go with what's on the board itself, what's on the circuit board. And so the service manual isn't always going to be correct. And so just make sure that you're double checking with what you're actually pulling out of the board as you do this. And so I've already gone ahead and looked, and I've made a list of all the caps that I need for this, and made sure my substitutions are appropriate. And so when we look at this capacitor, guys, there's a long leg and a short leg, and that long leg indicates the positive side of the capacitor, and that short leg, where the stripe is on the capacitor, indicates that's the negative side. And that's super important, guys, because when we go ahead and put this onto the circuit board, it's going to tell us, basically have a plus sign on the side where the positive leg goes. And so that's very important when you're doing this, that you do that correctly, or else you could risk damaging the unit, or it may not work. So make sure you're paying attention to that. The other question I got a lot, because I mentioned it on one of my previous videos, was about upping the voltage. And so I want to make sure I'm very clear on this. So when you're, especially in the power supply section, guys, I will oftentimes increase the voltage. However, my capacitance stays the same. So sometimes manufacturers, in order to cut costs, they put a capacitor in there that was just enough to handle the voltages that might be on that circuit board or not. And so really they can get pretty close, and then it shortens the life of that capacitor over years and over time. So a lot of times I'll go ahead and I'll increase the voltage just to kind of account for that, and just to give myself a little more breathing room when we're using these components. So on this particular power supply board, I've done that with every single electrolytic capacitor. And it doesn't have to be complicated. If I saw something that was 35, I put a 50. And if I saw something that was 16 volts, I put a 25 volt in. And so just a good rule of thumb, especially when you're in the power supply section, to go ahead and increase that voltage. So I think that covers everything that I wanted to talk about, guys. So now all we have to do is start taking out some of these components and swapping out new ones. And so I think how I'm going to do this is I'm going to do the transistors first, and then I'll move on to electrolytic capacitors. But if this is your first time, guys, take a picture of this if you're not familiar with it. That way you can have kind of a point of reference, and then pull one out, put one in, pull one out, put one in. It's very easy when you have this many components to get confused and then make an inappropriate substitution. And then double check your work. I can tell you that I've fixed and worked on probably at least 100 plus stereo units, and even I will make mistakes, and I'll put a component in backwards. Either maybe I was doing something, I got a phone call, and then I came back to it and did it wrong, or I was interrupted by my wife asking me to go do a honey-do list thing. But we're all human, we all make mistakes, so double check your work, especially when you're looking at the pinout on your transistors. So I'm gonna let you guys stick around for the ride. I'm not gonna talk about unsoldering these components. When I unsolder my components, I'm using my Hacko desoldering tool, and I love this thing. It's worth its weight in gold. So, but use whatever method you guys have to use. And then I'm going to go ahead and start swapping out these components. You guys just stick around for the ride, and we'll meet back here when we're done. All right, guys, so y'all probably saw me. There's a lot of glue on this board, and so that glue can be corrosive over time. And so I was trying to get a lot of it out. I won't get all of it out. Like anything that's not touching a leg of a component, I usually don't mess with. You can use acetone to soften it up if you're having a hard time getting it off as well. But I noticed that it was wrapping this resistor up here, and y'all probably saw that. But as I went to try to clean this up, the resistor broke in half. And so that just goes to illustrate how much this glue can cause a problem. So anytime you see it around one of your components, especially on the legs of the components, it's a good idea to go ahead and get it off. If it's just touching board, not as big a deal, but I try to get it off as I work. So I'm going to go ahead and replace that resistor. It's actually a paired resistor on each side, and so there's glue all over this resistor as well. So I went ahead and just pulled both of those resistors out, but I'm going to go ahead and replace those resistors as well. So I just wanted to give you guys a heads up as to what I was doing. So all these capacitors are the exact same size, so I'm going to go ahead and swap those out, and this thing will be good to go. And then I'm going to take a look at this fuse holder and see if I'm going to do anything about that, or if I'm just going to leave this soldered in. Preferably if I've got this holder and it'll fit in this component, then I'm going to try to replace it so it just is as close to original as possible. So let me go ahead and finish doing this, but I just want to let you guys know that's what happened, is that resistor broke due to corrosion because of this glue. So. All right, guys, so we've got all our components soldered back in, and so it wasn't too bad. The biggest thing was just this glue, getting this glue off, and so we talked about the resistor getting corroded and breaking off, so I went ahead and just replaced those two resistors. We've got all the transistors and capacitors in there now, and so the next thing I'm going to do is I'm just going to look and see if this will come off easily, and if the fuse holders that I have will actually work here. If not, we'll just leave it the way it is, because there's nothing wrong with this. It's secure. It's not, well, it was secure. So maybe we'll go ahead and take that off. And so we'll address that somehow and figure out what we're going to do there. And it may be that we just solder this in place if my fuse holders don't fit in that configuration, but we'll see. So I'm going to go ahead and do that. I'm going to do that off camera, guys, because I'm going to have to get my hands in here pretty good. And so, but we'll come back after that, and I'll let you guys know how I decided to fix that and what I did. All right, guys, so got these new fuse holders in, and so that went pretty well without a problem. And so while I was doing this one decided to break, so I had to go ahead and do that. And so I think that just illustrates that you never know what you're going to get into when you're restoring vintage equipment. Anything can break as you're doing it. And so sometimes it doesn't even need a reason. So I went ahead and kind of pushed on these two just to make sure they were solid. But probably when someone had, so that one seems a little weak to me, when someone had swapped out fuses in the past or for whatever reason, these have become brittle and they've broken. And so now we've got this. So that's probably going to stem a problem down the line. That won't be a problem in the future now, along with the corrosion that we found on these resistors that we talked about. So now this is ready to go back together. And so the installation process is going to be basically just the reverse of how we took it out. And so we'll have to just be careful and just slide it back in with the wires, and then kind of reconnect our ground here and put in those couple screws. And then we'll be ready to call this a wrap today. And so before I do that, I'm going to go ahead, actually, you know what, I'm going to go ahead and do that. And then before we end for today, guys, I'm going to test all the capacitors that we took out, and then kind of give you guys a rundown of how many capacitors were in spec and how many were out of spec. So you guys stick around, and I'm going to go ahead and put this in, and then we'll meet back up in just a few minutes and talk about the capacitors that we pulled out. All right, guys, so here we are back on the bench. And so these are all the components that we took out. And so we took out 17 electrolytic capacitors, 5 transistors, 2 resistors that were corroded on their legs from that glue. And we wound up doing 3 fuse holders. And so that third one that I thought looked kind of suspicious was broken as well, so I went ahead and swapped that out. So of the 17 capacitors that we took out, guys, 7 of them tested perfectly fine. They were within their capacitance ratings and their ESR was low, so these were pretty good. There were 6 of them, though, that I would put in the category of probably fixing to go bad at some point. So they were right on the cusp of their outer limits of capacitance and ESR. And so these will probably go bad at some point. You know, that it's hard to say. That could be a week from now. That could be a month from now. Could be a year from now. But these are suspicious, I would say. And then we had 4 that were just completely bad. Either they had their capacitance was way off or the ESR was really high. And so I think it's very valuable to do this in your vintage electronics because you really never know what you're going to get. And after 40 years, these capacitors have done their job. And so it's time to go ahead and swap them out. And so I know a lot of people will say you should never just do a shotgun approach and change all your capacitors out. But, you know, really, if you plan on keeping the equipment, it's really going to make the equipment last a lot longer. And then you won't be worried about it just breaking down on you one day. And so especially in the critical areas, you know, like the power supply, the amp board, and protection circuit as well. And so again, when you do this, though, you never know what things you're going to find. And I think there's value in just doing this because you may wind up having to replace other components that would have failed, like these resistors. This resistor, it was a ticking time bomb. This is only a matter of time for this to fail. And then these transistors as well. So let's go ahead and put the stereo back up on the bench. Now that we've done it all and got it all back together, let's plug it into our dim bulb tester and make sure we still get relay click, and then we'll call it a day. Okay, so we finished recapping the power supply. We've changed out the transistors, and we've also changed out some other parts that went bad. So it's a good idea before we move forward to plug it into our dim bulb tester. And so I do recommend that anytime you've done especially any type of major repair, that you go ahead and plug it into your dim bulb tester just to make sure you've done everything right. There's not any shorts or any problems. And also before we proceed to the next part of this restoration, it's a good idea to plug it in and just make sure you still get relay click. So let's go ahead and turn it on and see if we still get relay click. So my dim bulb went out. And there's our relay click. So that means we've done everything right. We're not having any issues with the repair. So I hope this was valuable for you guys today. Thanks for tagging along. And as always, thanks for watching, and we'll see you on the next video.